All right, continuing with 6.1. We just talked about the uniform distribution, so now we're talking about the normal distribution. This one is huge. We're going to be using this throughout the rest of the semester. All right, so if a continuous random variable has a distribution with a graph that is symmetric and bell-shaped, we've talked about this thing before, we say that it has a normal distribution. Now, I don't want you to freak out at the next thing that pops up on here. I'm not even going to leave it up for very long. For any of you who may be interested in algebra, what comes up next is the actual equation for the normal curve. And it looks like that. All right. We will never, ever use this in here. Okay, so I'm not even going to leave it up there. All right. This is what we're talking about. So if you were to graph that equation that was on the last slide, it would look like this. The graph would look like this. Okay. So remember that probabilities for continuous random variables come from area under a curve. So imagine taking a little slice out from under this curve. That's going to represent a probability. Okay, so we're going to talk about how to figure those out. Okay, first we're going to start with the standard normal distribution. A normal distribution is distinguished by its mean and its standard deviation. So if you tell me the mean and the standard deviation of a normal distribution, that tells me everything I need to know about the normal distribution. Those are called the parameters of the normal distribution. So every time you change the mean or the standard deviation, you get a new normal distribution, which could potentially create a little bit of chaos. Okay. So to make things simpler, every time we do a normal distribution problem, we will always relate it back to the standard normal distribution. So that's a normal distribution with a mean of 0 and a standard deviation of 1. Okay. The values of the random variable in that standard normal distribution are z-scores. Remember, we talked about z-scores before. Okay. And we can find areas for different regions under this curve by either using technology, which I'm not going to talk about very much, or we can use Table A.2. So the group that is sitting in front of me right now just got a copy of Table A.2. And for those of you who are watching the video, I'm going to try to figure out how to post a link to it under the video. It'll pop up during this part of the video. If I click on this here, it should come up. There it is. Okay. So I'll bring this up as we're doing our examples. Okay. When you're using Table A.2, it's important to understand a few things. Number one, it's designed only for the standard normal distribution. Now in this section, that's all we're talking about is just the standard normal distribution. But in the next section, we're going to allow the mean and the standard deviation to be whatever they are, okay? So when we get to that section, the first step will be to convert it over to standard normal distribution. Okay, second thing is that this particular table is on 2 pages. One side of the page has negative z-scores, the other side of the page has positive z-scores. So make sure, and it's kind of difficult to mess that up, all right, depending on what kind of problem you're doing. And then the third thing, this is super, super important. Each value in the body of the table is a cumulative area from the left up to a vertical boundary above a specific z-score. So let me pull that table back up. Actually, I have it open here. So you see this picture on top with the normal curve, and there's an area shaded on the left side, all right? These standard normal distribution problems actually come in a few different flavors. The three most common kinds are an area on the left, an area on the right, or an area between two values. Okay. So if you happen to be dealing with an area on the left, this table will give you the answer that you need. However, if you're dealing with an area on the right or an area between two values, then you have to tweak it a little bit, and we'll talk about how that works. Got some great examples coming up here. Okay, so let's put this back. Okay. All right, when working with a graph, avoid confusion between z-scores and areas. Let me bring this thing back again. The z-scores are listed in this left column. All right, actually it gives you part of the z-score there and then the hundredths place. You may remember when we first started talking about z-scores, we said we were going to round them to 2 decimal places. So if I'm dealing with a z-score of, let's say, negative 2.42, the way that I'm going to find that is I'm going to go to negative 2.4, and then I'm going to go over to the column that has the 0.02 on top. Okay, so that row and that column represents a z-score of negative 2.42. You get the first part over here, and then you get the last digit up there. Okay, so those are the z-scores on the left column, and then the last digit on the top row. All of these numbers inside the table are areas. Okay. So there's a couple different kinds of problems. Most of the time you're starting with a z-score and looking for an area, most of the time. But sometimes you're looking for an area and trying to trace it back to the z-score, okay? So when you get to that kind of problem, you have to find the area inside the table and figure out what z-score it goes with, okay? This will make a lot more sense when we do some examples. And those should be coming up pretty quick here. Okay, z-score is the distance along the horizontal scale of the standard normal distribution. So there's a number line along the bottom under the curve. And remember that z-score represents the number of standard deviations above or below the mean. Okay, we already talked about where to find the z-scores in the table. Area is the region under the curve. Those are the values in the body of the table, inside the table. And we talked about the hundredths digit of the z-score is on the top row. Okay. This slide just mostly talks about technology and also the table. So the table gives you area from the left. And these programs also give you area from the left. Okay? There are a couple of programs or technologies that you can use to find area between two boundaries. So that picture looks like this. One of them is your graphing calculator, your TI-83 or 84. Oh, maybe I'll show you how that works in a little bit. Or if you're using this program called StatCrunch, which I don't use. Okay. All right, finally an example. A bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of a bone density test is commonly measured as a z-score. So it makes for a great problem in this section. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So these test results meet the requirements of a standard normal distribution. Okay. The graph of the bone density test scores is shown here. Actually, I think I grabbed this picture from somewhere else. A randomly selected adult undergoes a bone density test. Find the probability that this person has a bone density test score less than 1.27. Okay. All right, so I did a little bit of tweaking with this PowerPoint before I showed it to you. The pictures that they had in here kind of had some spoilers in them. was all marked up with practical. I think the answer was written on it already. So I didn't really want to use that. So I went on to Google Images and just found sort of a more generic picture. All right, so what's going on in this picture is this z-score here is 1.27. That was given. Okay. All right. So now this is exactly the kind of problem that the table is designed for. Okay, it's an area to the left. So I'm just going to go ahead and back out of my PowerPoint again, and I'm afraid that that 1.27 is going to float around there for a little while. 1.27 is a positive z-score, so I'm going to go onto that side of the table that says positive z-scores on top. I'm looking for a z-score of 1.27. So I'm going to go down here to where it says 1.2. And then I'm going to go over to the column that has the 0.07 on top. Okay. So I believe what we're looking at is this 0.8980 here. See that? Okay. So that represents the area under the curve to the left of z equals 1.27. Okay. So now I'm going to go back to my thing here. And let me get rid of, oh, I guess I have to get rid of everything. Okay, so I'm just going to point at this and say that that area, oh, I'm so not good at writing with the mouse, is 0.8980. 8980. So that's going to be the probability that we want. Okay, it's that simple. You just find the answer in the table. Okay. All right. So again, here's the table. They've cut out just the part of it that we need. Okay, so there's 1.27. There's the area of 0.8980. All right, so that area to the left of z equals 1.27 is 0.8980. And that's also going to be our probability. The probability is the area is the probability. Okay. They kind of draw this out a little bit. Because of the correspondence between area and probability, we know the probability of a z-score below 1.27 is 0.8980. Okay. All right. Another way to interpret this is that 89.8% of people have bone density levels below 1.27. All right, using the same bone density test, find the probability that a randomly selected person has a result above -1.00, which is considered to be in the normal range of bone density readings. So once again, I think I took out the picture that they had in here that was all marked up with the answers and everything, and found this generic picture on Google Images. So it's just showing me some generic area to the right. And so I want to know what is the area to the right of -1.00. So now I have to start being careful, right? If I go to my table, there it is. I'm going to go over to the negative side because we're looking for a z-score of -1.00. And that's all the way down here. And then the hundredths place is also a 0, so I'm looking in the very first column, 0.1587. Okay. So think about, is that my answer? Okay, remember that this table gives you the area to the left. Okay, so that's almost the answer, but not quite. What you have to do with that answer when you're looking for an area to the right is you have to subtract it from 1. So you're using the complement rule. Since the area to the left of negative 1.00 is that 0.1587 that we just found, that means the area to the right is 1 minus 0.1587, which gives you 0.8413. Okay, because the total area under the curve is 1. That's why you subtract that area from 1. Okay. So your answer is 0.8413. It is not 0.1587, so be really careful about that. All right, so the probability of randomly selecting someone with a bone density above -1, greater than -1, is 0.8413. So about 84.13% of people have a bone density test in the normal range, right? That's how they pick the -1. Okay, and then the last kind of problem with standard normal distribution, at least for finding a probability, is between two values. Okay, probability that the z-score is between two values. A bone density reading between -1.00 and -2.50 indicates the subject has something called osteopenia, which is some bone loss, like moderate bone loss. Find the probability that a randomly selected person has that condition, okay? Because they have a z-score between -1 and -2.5. Okay, since we're looking for an area between two z-scores, and my table only gives me areas to the left, here's how I have to do it. First, I'm going to look up z equals -1.00. We had to do that in the last example. Remember, it was 0.1587. And then we have to look up the area to the left of -2.5, which is only 0.0062. Okay? So since the area that I want is between here and here, if I started here and went all the way to the left, that would give me the 0.1587. If I started here and went to the left, that would give me the 0.0062. And since I don't want that latter area, I'm going to subtract it out. Okay. So that's how you do that. When you're looking for the area between two z-scores, you look up the two z-scores and then just subtract them. All right, for any of you who might be using a graphing calculator, I'll show you really quick how you can get this out of the graphing calculator. I'm only going to do this for area between two values. You actually can use the graphing calculator for any kind of standard normal distribution area problem. You could use it for the first two we went over. You have to cheat a little bit to do that kind of problem, but it is doable. Okay. So the way you bring up the stuff for your normal distribution is you go second and then this VARS button. Notice it says DISTR on top, which stands for distributions. So when you hit second and then VARS, I'm sorry, let me do that again. It might be helpful to follow my key press history over here, and I forgot to clear it. So second, VARS. And then select number 2, which is normal CDF, normal cumulative density function. Okay. Now, on this particular calculator, the parameters are just the lower limit and the upper limit. Okay, and you do have to put them in order. So put the -2.5 first, and then put a comma, and then put the -1. Okay. Now on some calculators, I actually like this kind better. A little menu will pop up after you hit normal CDF, and it will ask you what's the lower limit, what's the upper limit, and what's the mean, and what's the standard deviation. So if you're working in standard normal distribution, put these as your lower and upper limit, and then remember the mean is 0 and the standard deviation is 1. And then I think there's something on the bottom that says paste. So you click where it says paste, and then it will put it in this screen. Okay. So if I put it in like that and I hit enter, it gives me almost the same answer. If I rounded that to 4 decimal places, it would give me 0.1524, but that's pretty close. Okay. Okay, so the interpretation of that problem, the probability is 0.1525 that a randomly selected subject has this osteopenia condition because their bone density reading is between -1 and -2.5. Okay. All right. Now, let's see. Okay, so again, to find the area between two z-scores, you subtract two numbers that are found in the table. Don't try to memorize a bunch of rules, all right? So what I always recommend is as soon as you're given a normal distribution problem, draw a picture and understand, are you looking for an area to the left, an area to the right, or an area in between? Okay. And as long as you understand that your table only gives you areas to the left, you should be able to get those without having to memorize a bunch of stuff. Okay, so the notation that we will usually use for these probabilities, like the probability that z is between two given values, that's just the probability that z is between a and b. A is less than z is less than b. Okay? So like that last problem that we did would be written the probability that -2.5 is less than z is less than -1. Okay? That's how we would write that. Okay. The example before that, where we were looking for the probability that a person's in the normal range, right, greater than -1, that would be written like this, the probability that z is greater than -1. And then the very first example, the easy kind, the kind where the answer just comes right out of the table, that would look like this, the probability that z is less than 1.27, for example. Okay, now there is another kind of standard normal distribution problem, and that's where it's kind of the backwards version of what we were just doing. So I'm given an area, and I have to find the z-score that goes with that area. Okay. All right, so you're going to start by drawing your bell-shaped curve, identify the region under the curve that corresponds to the given area or given probability. If that region is not a cumulative region from the left, convert it into a cumulative region from the left. Okay. This kind of problem, it's usually, but not always, either an area to the left or an area to the right. It's kind of hard to make area in between problems out of these. Okay. It is possible, they're just not as common. All right, and then use technology or the table to find the z-score that goes with that area. Okay. Now, most areas are not listed in the table, okay, because those area numbers kind of skip around. You'll see what I'm talking about here in a minute. So if the specific area you're looking for is not in the table, then just pick the one that's the closest. There is something called interpolation, where you kind of estimate the best z-score that goes with that specific area that you're looking for. And I used to teach that in one of my other classes. I think it's getting a little obsolete because I would rather use technology if I'm trying to be that exact. Okay. One type of problem where we're going to be looking for a z-score from a given area is called a critical value, finding a critical value. So a critical value is just a z-score that separates scores that are either significantly low or significantly high. Okay. For example, let's see. Oh, and then notation, and then I think we get to the example. This expression z sub alpha denotes the z-score with an area of alpha to its right. And I don't have a picture of that, so I'm going to try to draw one. Okay. So here is my normal curve. Not too bad. So let's say that this area here is alpha. Alpha is some small number like 0.1 or 0.05. Okay. The z-score that separates that area is called z sub alpha. Okay, and you're going to see an example of that coming right up. Okay, so the first example of finding a critical value, they want me to find the value of z sub 0.025. Okay, so I still have my picture up here. That means I'm looking for the mystery z-score that separates an area of 0.025 on top. Okay, let me get my pen back out here. So this area is 0.025. Okay. So the very, very first thing I have to do is I have to remember that my table is not designed for areas to the right, it's designed for areas to the left. Okay. So now I'm going to go over here and I'm going to say, okay, if the area to the right is 0.025, then the area to the left must be 1 minus 0.025, right? And 1 minus 0.025 is 0.975. And I'm going to write it as 0.9750. Okay? Because all the areas in the table have 4 decimal places. So that might make it a little easier to recognize. Okay. So now I'm going to try going over to my table and leave this picture up. I don't really want to clear the picture just yet. I hope that's not going to be too annoying. Okay. All right. So it's a little more difficult to find your specific areas. Okay. Sometimes it feels like looking for a needle in a haystack. They are listed in order at least. Okay. So for one thing, I'm going to find this area on the positive side of the table. I scroll down, scroll down, scroll down, and eventually, there it is. See it? 0.9750. And that area goes with a z-score of 1.9. Of course, I cut off the top. I think it's 1.96, right? 1.96, there it is. Okay, so now let's move this back. Okay, so that mystery z-score is 1.96. Let's scribble that in there, 1.96. Oops, okay. All right, so now I think I'm ready to go to my next slide where this is kind of all written out already. Let me get this out of here and put that back on. Okay. And I'll get rid of this now. Okay. Note that the value z equals 1.96 has an area 0.025 to its right. Okay. Notice that z sub 0.025 corresponds to a cumulative left area of 0.9750. That's how we found that, right? Locate 0.975 in the body of the table. Okay, so here they're just warning you, remember that alpha is the area to the right, but the table is set up for area to the left. Okay. So your first step when you're finding this mystery z-score is to find the complement of the area that's given. Okay, 1 minus the area that's given. Okay.